Alright, good afternoon. Kamusta na kayong lahat? Sorry, medyo hindi ako nakapag ano. Anyway, this is my late uploading of my lecture on FM. Naka-share na tayo, no? Let me check. Okay, naka-share tayo. Okay. Alright. FM. The topics on chapter 5 of PrinCo book are basic principle of FM, frequency modulation, and then the technology, the next technology of FM, which is the phase modulation, and the parameters of index and sidebands, noise suppression, that effects of FM, and the FM versus AM. Okay. So, pag sinabi natin FM, so we define is the sine wave carrier can be modified for the purpose of transmitting information from one place to another by varying its frequency, not the amplitude. And we call it the FM. In FM, the carrier amplitude remains constant and the carrier frequency is changed by the modulating. So mapapansin nyo, in this waveform, so figure A is your carrier, ito yung oscillator ng transmitter, and then B is the voice produced from the transducer coming from the announcer, MP4, whatever it is. And then C, the effect of your signal, and that is your FM. Okay. For better transmission, you can convert that with what we call phase modulation. So as the amplitude of the information signal varies, the carrier shift proportionally. So mapapansin nyo. Okay. So magpapagsulat tayo. Okay. Pen. Black. Okay. So in the form of this, we have a new, it affects the carrier. So at the peak, on positive, you will notice here at the peak, we have a high frequency. Itong baba. At low frequency, at lower part of the audio signal, the FM will be a less frequency modulated. Okay, with a fixed amplitude, and these things also just copied, but in a different phase difference. Okay. So focus yung mga label yan. Okay, nagkakaroon siya ng phase change on this area. Okay. Parang hindi naman siya nag-lead siya, hindi siya nag-lag. Nag-lead siya. And that's because of passive component. When the amount of phase shift of a constant frequency is varied in accordance with the modulating signal, the resulting output is phase modulation. Yung kanina. Yan. Ito, PM na to. Yung pang-apat na signal. Phase modulator, the transmitter, produces a phase shift, which is a time separation between two sine waves of the same frequency. So nagkakaroon tayo ng separation of time. See? Yan. Karoon ng different time. Ito yung time na to. Ito. Yan. At saka itong time na to. Oops. Yan. Okay. Alright. The greater the amplitude of the modulating signal, the greater the phase shift. Okay, so the greater the amplitude. So pag nasa taas, ayan, nandito tayo sa area na to, nandito tayo sa area na yan. So we will notice ahead siya. The greater. Tapos, pag nasa negative siya, okay, medyo konti lang yung ano, no? Konti lang yung phase difference. Okay. And the maximum frequency deviation, because of that, nagkaroon tayo ng deviation produced by the phase modulator during the time that the modulating signal is changed in most rapid rate. Okay? Ayan. So kung kukunin natin yung kanilang mga limits, okay, yung kanilang 3 dB point, no, kaka-create tayo ng index or a frequency shift occurs in PM only when the modulating signal amplitude varies. Okay. So pag walang modulating signal, walang PM nangyayari. Okay. May na index. Now, o in deviation na kinatawag. Now, what will be now the relationship between the modulating signal and the carrier deviation? I think the carrier deviation is this. Ganyan ang tawag dyan. Bilog siya, tapos may konting ganun. Yan, modulating index yan. O, deviation yan. In FM and in PM, the frequency deviation is directly proportional to the amplitude. So, malaki ang deviation pag nasa peak siya ng modulating signal. In PM, the maximum amount of leading or lagging, ito yung sinasabi ko, no? Of course, leading yun, ano? Kasi nauna siya in PM. Okay. In PM, the carrier deviation is proportional to both of the modulating signal and the amplitude. Yan. So, hypothetically, the phase modulation versus so we have modulating signal. So, as the so the graph tells us the deviation versus the modulating signal. Ayun yung symbol, oh. Ito mas ano itong symbol na to. Ito yung deviation. Itong symbol na to. Yan. Ewan ko ang tawag sa Greek na yan. Hindi naman, ano yan. Ano na. Tignan lang natin. Versus the modulating signal. So, on figure A, that is the modulating signal amplitude. Okay. So, directly proportional. Okay. And modulating signal frequency on B. Okay. For FM. Okay. So, kanina, sa A, yung frequency deviation as a function of modulating signal and as a function of frequency, amplitude and frequency. Okay? What is the principle of phase modulation? We convert PM into FM. In order to make PM compatible with FM, the deviation produced by frequency variation on the modulation must be compensated. So, mako-compensate lang yan pag meron kang gumagamit ng mga low-pass filter. Okay. And the FM produced by the voice modulation is called now indirect FM. So nakakategorize na natin kung direct and indirect FM. So the phase shift keying, ito na tayo, now we are shifting the analog to digital. So is it possible? Yes, by converting this another technology, the FM signal into a binary data. Okay. And then the PSK signal has a constant frequency, but the pace of the signal from some reference changes as the binary modulating signal occurs. Tingnan natin. Ayan guys. No? So pag may binary ka from 0 to 1, nagkakaroon ka ng phase shift of 180 degrees. From 1 to 0, another phase shift. Okay? That's how we convert the FM to PSK, phase shift or binary PSK. Now, kung may index sa AM, meron ding index sa FM. So how do we define the index? First, any modulation process produces sidebands. Okay, so kung may sidebands sa AM, meron din sidebands na. Kahit yung TV meron eh. When a constant frequency sine wave modulate a carrier, two sides frequency are produced. Okay. Anyway, alam naman natin lower sideband, upper sideband. Ayan. So, anyway. Ayan. So, pag meron kang carrier, alam naman natin to, this is a basic. Ito yung carrier, meron kang lower sideband and upper sideband. Okay. So, side frequencies are the sum of the difference. Ito din yung ano natin sa AM. Alas pareho lang sila. The bandwidth of the FM signal is usually much wider than AM. No, yung bandwidth, ito. Much wider. So, the bandwidth ng FM is FM. And is greater than the bandwidth of AM. Okay. This. And imagine ang layo, doon na lang makikita mo na lang from 1650 kilohertz, the maximum allotted for AM, kumpara mo sa 108 megahertz. No? Kahit 88 to 108 yan, ano yan, no? Ibang ano yan, marami kang pwedeng ilagay na station. So the index also is the ratio of the deviation. Okay, the ratio of the frequency deviation to the modulating frequency is what we call modulating index. We have problems, and in most communication using FM, maximum limits are put together as per agreed and how do you call that? Directed by the ITU and implemented by the NTC. So you have a 75 kilohertz deviation and over 15 kilohertz, so you have 5. So meron kang index na 5. At pag may index ka ng 5, no, makikita mo sa Bessel function kung ilang harmonics ang pwede mong ma-produce. Okay? Yan. Kung 5, nandito ka. Ayan, 5. Oh. Yan yung index mo. So, meron kang umaabot ka hanggang 8 side bands. From left to right. 8 yan. 4-4. Okay? Okay? Pag modulating index mo 5, somewhere here. Okay? Ano ba yung sa kaliwa? That is ano ba yung J of N? Tingnan natin. Ayan. Okay. Tingnan natin. Okay. Sa vessel function tong J. Eh. So J sub 2. No. You have J3. Okay. Ano ba yung J3? Teka natin dali. Tama naman. 3 to 4 siya, di ba? 3 to 4 eh. 3 to J3 to J4 ang inyong side bands. Okay? Ayan. Pag index mo is 0.5, so meron kang dalawang band. Tingnan natin. 0.5, masyado mababa. Tama, 1 lang eh. J1 ka eh. Ayan o. Pag 0.5, ito lang yun. Oh. So 1. 1 to the left, 1 to the right. Kung 6, 6 is 9. Kung 6, 9. 4.5 eh. J4 to J5. So, pag sinabi natin harmonics, guys, kung ito yung, sabi kanina, yung drawing na kanina. Yan. No, meron ka pa dito. Meron ka pa dyan. Yan. So, yan. Ano yan? Meron kang 4 harmonics. Okay, tapos may isa pa dito. So, that is 6 harmonics. Okay? So, the basic, the standard is 5, no? Makikita natin ang epekto niya pag maraming harmonics. Pag maraming harmonics na more than 5 or 6, 7, no? So, malabas na you, no, you are tuning of a lot of ano na pag broadband siya. So, marami kang possible. Kaya ipipix natin sa 3, sa 5. Okay? So, the symbol factorial, no? So 5, that is 120. So if you have a index of 5, factorial mo yan, 120. In a narrow band FM, in which the modular index is less than pi over 2 is 1.5. So this is another requirement or standard na yung modulating index mo must be pi over 2. Now, in a narrowband FM, which is commonly used, okay, the, the spectrum space of the express signal to noise must be fall on this, okay, on this requirement, pi over to 1.57. Ah, so pag sinabi ng narrow, no, uh, of course, you have broadband and narrowband, okay? Pag ang ano mo is a narrowband, so your upper sideband and lower sideband will have a limit of 1 to 1.7 or 1 to 2. No? Kasi 1.57. Okay. Titingnan natin, no? Itong 120, no? Saan gagamitin. Alright. So the higher the modulating index in FM, the greater the number of sidebands and the wider the bandwidth. So yung kanina na 5, that is a broadband, no? Wider. Pero pag if it is a narrowband, so mga 1.57 kanina, no? 1.57. So when spectrum conservation is necessary, the bandwidth of an FM can be restricted by putting an upper limit on the modulating index. Maganda rin kasi yung ano, no, may mga advantages ang isang broadband sa isang narrowband. Maraming mga advantages and disadvantages. Pero for the meantime, i-maximize natin yung formula. If the highest modulating frequency is 3 kHz, so 6 over 3, and the deviation is 6 kHz. So you have 2. So if meron kang index na 2, so meron kang, so the bandwidth is 24 kHz. So ano yung ano, kung pupunta ka sa Bessel function 2, ayan 2, ito 2. Ito yan. So meron kang J1 times 2. Okay. So meron kang the sidebands are those having an amplitude of greater than 1 or 0.01 in the Bessel function. Mga 0.5 less than 0.01 eh. Ano sabi? Wait lang. Significant sidebands are those that have an amplitude of 0.01 in the Bessel function. Greater than. So, mapapansin mo nga, no? So, from 1 to 0.9, 0.8, 0.6, 7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1. Okay. So, doon mo lang makikita yung mga sideband pag greater than 1%. Okay. So, in FM, meron siyang circuits na noise suppression. So, because due to lightning, motors, automotive ignition, and other power lines, nagpo-produce ng trans signal. Noise is typically narrow spike. Okay? Ayan, yung mga narrow spike. No? So, there are part of the narrow spike of voltage with high frequency. Okay. Of course, no, kasi pag nag-spike ka dyan, no, so big sabihin, the frequency is, kasi frequency din yan, nag-produce ka ng positive, pataas, tapos nagpababa ka rin kung spikes yan, di ba? Yan yung spikes. So, tumataas ang frequency mo. Noise is typically narrow spike with high frequency. So, noise voltage spikes add to a signal interference. So, some noise completely obliterates. So, it affects the original signal. So, the FM signal have constant modulating carrier and the FM receiver contain limiter. Okay? So, sa receiver, papasok yan sa isang tubo. No? Tubo is not literally a tube. No? It is an RC or RLC. No? Passive component on which may capable siyang tanggalin ang mga spikes na yan. Okay? Ang tawag doon limiter. Ayan, limiter. Ayan, may limiter. Circuits to eh. Ang AM walang limiter. Pag nilagyan mo ng AM na limiter, wala ka nang maririnig. FM lang yan. Wala ka pala maintindihan. Any amplitude variation occurring in the FM signal are affected by clip and limiter circuits. So, dito papasok yung ano nyo, no? These circuits in the form of RLC are categorized as part of clipper. Ito pala, ito, clipper circuits, no? Kung maalala nyo yung mga ano, no, may kasamang diode din pala to kasi clipper circuits eh. Kung naalala mo yung sa basic electronics nyo, which is under diode and capacitor, okay, and resistor, no, meron tayong bukod sa rectifier, meron tayong clipper, okay, in the form of clipper and clamper. Pero usually ang clamper, tinataas niya yung signal, pero ang clipper is more on limiter, okay, pinuputol niya yung sobra sa amplitude. This amplitude clipping does not affect the information since it is contained slowly with the frequency variation. Okay, so kung mapapansin mo, ito yung original signal mo eh. Hindi maapektuhan yan. Hindi maapektuhan yan kahit marami pa yung mga spikes na yan. Dadaan ng clipper. Ano ba laman ng clipper? Resistor, usually may diode yan. Capacitor. Yan. Kung wala capacitor, inductor. Pwede yan. So, tama pala ng RC. No, tama yung binabanggit ko ng RC. RC o RL. Pero may konting diode yan. Kasi, di ba, napag-aralan nyo yan, di ba, sa power supply. Pag dumaan to ng diode, di ba? Pag dumaan ng diode yan, nawawala ang negative part, di ba? Yan. Nawawala to. Nawawala yan. Kaya natitira, ito na lang sa taas. Eh, kung dumaan nga ito ng ano, eh, puputulin talaga ng diode yan. Other passive component, but not transistors. One way also to contain, no, para maayos natin mga noise is using pre-emphasis. Okay? And the pag transmitter, pre-emphasis. Pag receiver, de-emphasis. Okay? So, noise can interfere with an FM signal and particularly with the high frequency component. So, noise is primarily sharp spikes, as I shown earlier, and contains a lot of harmonics. Especially, nagpo-produce din siya ng mga nth harmonics kung ikaw ay maraming harmonics. To overcome this, we need a technique called pre-emphasis. So, it's what we call high-pass filter. Can serve as a transmitter pre-emphasis and then the emphasis on the receiver. Okay, so kailan din ng mga amplifier No, pre-emphasis provides more amplification on high frequency naman. Okay. So it's not really an amplifier on which you need a transistor, but here it's more on frequency component. Pag sinabi frequency, no, LC yan or crystal. So ito yun, sa transmitter, kailangan natin ng pre-emphasis output pag nilagyan mo siya ng high pass filter, no? High pass filter. Ayun, high pass filter. Ayan, high pass filter yan. Okay. And pre-emphasis is a simple yan. Pag yung low pass filter sa de-emphasis naman yon sa receiver. Okay? Yung malitong title na to. Dapat at de-emphasis kasi we're talking now of receiver. A de-emphasis circuit returns the frequency response to its normal flat level. And then yung signal to noise ratio is very I would say evident that time. Okay. Ayan. Ito na yung receiver. Meron kang emphasis. Low pass filter ang ginagamit. So the advantage of AM/FM is, of course, the superior immunity to noise. Okay? Wala kang ka-noise-ness nga eh. So mas mo i-digitize mo pa yan. Okay? And then, FM has superior immunity made because of the clipper circuits. In FM, interfering signal on the same frequency are rejected. So meron tayong tinatawag na capture effect. And these are wave trap, no? Kaya nga ang inyong TV maganda ang video and audio because of the wave trap, which is the capture effect. FM signal has a constant amplitude and there is no need to use linear amplifiers to increase power levels. Okay. So, yung mga class A, class B, ibig sabihin, class A, B, sa receiver. Okay. Para gumanda pa. Kasi line of sight siya. Ang disadvantage naman, yung yung spectrum. Tapos the circuit is complex. Balik tayo sa FM uses kasi more frequency spectrum. No, kaya nga nagkakaroon siya ng mga sidebands, no, harmonics. Okay, in the past, ngayon, circuitry used for FM and the modulations involved were complex with the IC proliferation na outgrow na yung mga Kaya nga yung gagawin yung AM, FM, maybe the form IC, it doesn't matter. No? Kasi mas mahal yun. Kung ang gagawin nyo ay using too many components, mas maganda yon. May nagtanong nga, sir, paano pwede ba mag-pre-synthesize? Pwede naman, no? But be sure you are not copying the package foil pattern, no? Yung foil pattern, ito yung original etch, no? Ng mga configuration ng mga copper. Nakasama dun sa kit. No? Dapat may konting deviation. Ano yun naman yun? Kasi hindi siya magandang practice. Okay? Discuss natin to. So yung TV sound FM. Yung picture is AM or vestigial sideband. Then we will discuss more on FM next meeting. i-discuss natin yung itong epekto ng J. Right? So that will be on chapter kasi 4, especially on the receiver. That is on chapter 6. After chapter 6, we will have our unit test 2, AM/FM. Okay? So that is it. That's it. If you have any question, you can call me or message me, but don't forget to subscribe below. Do not just like, subscribe. Malay mo, yumaman tayo. Kakasubscribe nyo. So I miss the whole group. Again, I wish I have two legs to Mr. Miranda para the other one will work on the subject and the other one also will work on the other I would say other responsibility. But as I told you before that we will finish the curriculum. Buti na lang online para meron tayong asynchronous na tinatawag. Okay, so thank you for listening. Thank you for watching my video and keep safe guys kasi sa August 6 hanggang 20 ay ECG. So yung mga matataba dyan, no? Salvatierra, ako, Diyos ko po, lalo kang lolobon yan. Miss Peña, Hans Peña, ikaw rin, isa ka pa. So marami sa inyo ang lumolobon na. Yung kay Mark Sobre Peña, hindi katawan ng lumolobo. Yung utak niya ang lumolobo sa sobrang pagmamahal niya. Kanino? Kayo ng bahala. Okay? So, thank you guys and have a nice day. God bless you all.